Hi, Mr. Carlini with another episode of Virtual Carpentry. So this is day 2. We are continuing on the wall framing that we started yesterday. We talked about load-bearing, non-load-bearing walls and partitions. So you can look back at the last video if you didn't get a chance to look at that. We have today we're going to talk about the components that are involved in wall framing. It's going to be a 2-dayer. We're not going to get through both of them today because it's just a little lengthy. But I wanted to take a moment and bring you up to speed on where we should be with the vocab sheet. So if you go online, which I posted yesterday, and I had said that you want to download this and you want to start filling it in. So yesterday we did walls, load-bearing, non-load-bearing, partitions, load-bearing, non-load-bearing. This was your assignment for yesterday. So today we're going to continue on this vocab sheet and we're going to talk about the next one. So we're going to start with plates and we're going to go on down through several of these. Okay, plates. Plates are the first thing that we lay out on the wall. It's where all of our layout is done. This is where we put all the markings of everything, and we can equate plates to floor framing. That would be the band joists where we did all of our layout marks on there. So these would be the plates. In a wall system, you have 3 plates for a typical residential framed wall. The bottom plate, we have the top plate and the double top plate, which is up there. Okay, so really when we start laying these out, and this is another day's exercise, we lay out the bottom plate and the top plate together, just like we lay out the two joists, or the 2 band joists. So this is wall framing. This is called plates, not band joists. The plates run the entire length of the building. Anywhere that you have a wall, you're going to have a plate. Depending on the type of wall, you may have 2x6 walls, such as these ones, or you may have 2x4 walls, as we have right here in this partition wall. So it's the reason that we go with thicker walls is because of the amount of insulation that we want to put in. Typically, that's the only reason that we're changing the thicknesses of the walls. But for most cases, 2x4 walls do suffice, except where you need excessive insulation, like on an outside wall, because of what the building code now calls for. The double top plate is an extra board put over top of the wall to allow to stiffen the wall up, that allows for when we have a splice in the wall, such as up. But right here we have a seam, we have a joint where this wall touches this wall. So how do we tie those together? It's with the double top plate. The double top plate on this wall runs clear through. It stops short, and the double top plate on this wall runs clear through over top of the load-bearing wall. And the other purpose is at butt joints in your wall. See how we have a butt joint on the 2 plates of the wall? Well, the double top plate splices that over. Now this piece of wood up here, don't confuse that with a wall component. That's just another scrap piece of wood that's nailed down over top. That is a drywall catcher. That's just something to screw drywall to. Bottom plate, top plate, double top plate. So we have our vertical members in the wall, the framing members. These are called studs. If you compare it to a floor system, like up there, those are called floor joists, but these are called studs. Okay, studs run from the bottom plate to the top plate, the full length. These are also known as king studs. That's, some people call them that. But if you just say stud, that's a common term meaning that it runs from the bottom plate to the top plate. A stud, when we do our layout mark, is signified by an X. So when we do our layout mark on the bottom plate, we're going to show you another day, the symbol is an X. We're squatted down here at the base of the window. The framing members that go across that hold up the bottom of the window, actually it doesn't hold up the bottom of the window, but it gives support to the shortened studs underneath the window. This component is called the rough sill. The rough sill is made out of the same material that the studs are made out of. Typically when it's installed, it's turned on a slight, up to probably about 6-degree angle, and it allows, if any water ever gets inside behind the window, to actually run out a little bit. So, but it's not super important that you put that little bit of cant on the sill, but I always like to do it. It's just a good practice. Since we're in the business of talking about openings like doors, window sills, rough sills, well, let's talk about something that doors and windows have in common in the framing aspect, is they both have studs that are in here that are common to both windows and doors, which are called trimmers. Now, what is a trimmer? A trimmer is a shortened stud that supports a load-carrying beam over top of the window or the door. They're both identical. They both work the same. But if you notice, when we cut a hole in the side of a building, especially in a load-carrying wall, which would be a load-bearing wall, we're actually cutting out several studs. A header is a component that we put into a wall system to carry the load. In essence, it's a beam. It's a girder, just not unlike a girder that you would have in the basement, holding up the center of the ceiling in the basement, center of the first floor. But when we cut these studs out, we do have to put something in there. So the weight comes down through these shortened studs, goes into the header, the weight is transferred out, and it goes into these shorter studs here, which are called trimmers. Okay, so a header is typically made up of several pieces of 2-by material. So let's take a peek right up over top of there, and you can see it's a couple pieces of 2x10. It's actually 3 pieces of 2x10 tripled up to give strength for that wall. Now, here are the trimmers, and these have to be set. The height of them has to be determined what they need to be, but that's another day's lesson. The trimmers are the shortened studs that hold up the header, whether it's a door or it's a window. And in this case, take a look. We only have one trimmer in here. These trimmers, one trimmer is good enough because look, we're really only cutting out 2 studs. And when I say cutting out, it's not like we frame the wall and then we get in there with a chainsaw and chop the opening out. We frame the window as we go. But we took out some studs above. We need to replace it with something, and that is what supports our header. Our header cannot simply just be face nailed into there and held up. No, and held in place with the strength of nails. It is going to be held with the strength of the trimmers. The trimmers, it's very, very important that the trimmers are nailed together with this stud. This is a king stud, the outside one. The inside one, the shortened one, is the trimmer. And it's nailed in a likewise fashion of sistering any wood that we do. So typically about every 12 inches, we have a zigzag pattern of nails between these two boards to make them one. They have to become one. If they don't become one, then you're defeating the purpose of what you're trying to accomplish here by strengthening it up. Trimmers, the bigger the opening, the more trimmers you need. This 6-foot opening has 2 trimmers on each side because there's such a big opening, and this being a load-bearing wall, it's carrying all the ceiling up there. So it takes a tremendous amount of weight because this is carrying everything that's sitting upstairs. This opening over here, as you can see, we ended up putting 4 trimmers, 1, 2, 3, 4, to carry that that beam up there. That's the header, okay? And we had to do the same thing on this side. We put 4 trimmers. So what is the marking? How do we mark on the sole plate and the top plate where a trimmer goes as opposed to a stud? Well, studs are marked with an X. Remember, a stud is a component that goes from floor to ceiling, from bottom plate to top plate. Trimmers go from sole plate to header. Under our windows, we have a component called a cripple stud. It is a shortened stud, very short. It's cut to the length that you need to go from the bottom plate to the rough sill. So that's all I can really say about that. Cripples are also used up top for over top of the header. They take up the space between the header and the top plate. Making up our corners of walls or partitions, we utilize something called a corner post. The reason we call it a corner post is because it's 2 components nailed together. They're just studs that are nailed together. Remember, studs are full length from sole plate to top plate. Corner posts can be made one of 2 ways. There's a more popular way that we're using nowadays, but when I got started on it, this was the way to do it. We would take, I'll show you a little drawing I have here. Let's look, this is looking down on your wall. So this would be a sole plate, this would be the other sole plate. And in here we would put together 3 studs. So we would frame this wall first and we would put 3 studs together. We would usually use blocks in between there. They call it an XBX corner for that reason. X being stud, B for block, X is a stud also. So that wall would be framed and we would put another stud here, and our other studs would be at 16 inches coming up this way. So this would make our corner. XBX posts are not the popular thing to use anymore. The problem being is that you can't get insulation behind there. So a new modern way to build corner posts is to do this, where we take 2 studs, and the best way to do this, honestly, is to nail these together in place on a set of horses so you can get the edges straight on them. You'll nail these two studs together. If it's a 2x4 wall, you'd be using a 2x4 and a 2x4. You would nail one this way, and you would put it into your wall system. So this would be a stud, and this would be a stud. And then we would frame the other wall and butt it to it, and there would be a stud against there. So now you can see how this makes a corner. This gives you screwing for your drywall into here and into here. It also leaves an open cavity for you to stuff insulation behind. You can also drill holes through this much easier and push wires through. It's a better system all the way around. This is why most builders have gotten away from the XBX corner post. So here's an example of one of these energy efficient corner posts. This is called the energy efficient corner post. So you can see this is a 2x6 framed wall, and we just took another 2x6 and we turned it flat ways, and it's touching the other stud, and that gives you a very nice corner. You have plenty to screw to, and look how easy it is to put those wires through. We drill one hole through and we could fish the wire in there. I could reach around back and pull it right around the corner. How do we make partitions come together into a wall or another partition? So this is called a partition post. Perfect example right here. We have a partition coming into this wall. So how do we meet it up? Well, once again, there's 2 ways of doing this, as we showed with the corner post. There's the old way, and there's the new modern way. So I'm going to show you the old way because a lot of people still do it this way. Here's our wall again, and here's our intersecting wall that is tying into it. So this would be your first wall that you have up, whether it be a wall or partition, doesn't matter. It's typically, this would be your load-bearing partition or wall if it is. and the other non-load bearing ones would butt into it. So the old way to do that would be to take 3 studs, full-length studs. We would put one here, and one here, and they'd be nailed together in a fashion that looked like a U. So, and the other intersecting wall would bump right into it, and it would be a stud against a stud. Once again, the problem is there's no insulation behind here. There is also, it's very difficult to get a wire to come around that corner. But with the green way of doing it, we have in our wall, we would have our normal studs in here wherever they fell, and we would put a wider stud in there than what we're using. So if this is a 2x4 wall, we would go up to the next size, being a 2x6. The 2x6 is wider than the wall, so it would be nailed onto the back side of this stud on the end of the wall. That allows you to put insulation behind here. It allows you to drill a hole and put wires right through. And that's exactly what we have happening over here. We have this intersecting wall or partition coming into this wall right here. And we made up the post. You can see it's just a 2x4 with backed up with a 2x6. Now it's going to let us put our insulation back behind there real nice. And if we did need to run wires through there, easy peasy, plumbing, whatever it may be. Drill one hole, put it through, turn the bend. The partition post length is determined by the length of the studs. It's basically just a stud that you take and you work into the wall system. So a load-bearing header is made up typically of 3 pieces of 2x. So we're looking down on that header. 3 pieces of 2x put together. Now it depends on the width of the opening, how much weight it's carrying above by how many boards you have to put into there. Typically if you put 2 or 3, you're okay. Over here, this being a non-load bearing wall, you can see we can get away without a header because there's no weight at all pushing down on here. The weight of this ceiling actually runs out to that, and there's a beam in that ceiling system which is carrying the weight. But this is a non-load bearing wall, so it needs no header. But any load bearing walls do need headers placed in. In this case, my engineer spec'd out 3 2x8s for over top of these windows, and he spec'd out 3 2x10s for over top of that door because it's so large. In other cases, such as garage doors where you're carrying a very wide opening with a lot of roof sitting on there, many times they'll spec out 3 LVLs, laminated veneer lumber. It could be up to 14 inches wide. So that's something you have to check with an engineer on. So how do we come up with the length of the headers? The header's length is determined by the opening width plus the thickness of all of your trimmers. Now remember, the bigger the opening you go, the more trimmers that you need to have underneath there. And a typical good rule to follow is for every stud that you have to cut, every full-length stud that is cut, and a cripple was put in there, you would need that many. So you would need that many trimmers. So look up, count how many cripples you have. That's how many trimmers you're going to need. I have 2, so I got 2 trimmers. Now bear in mind that you need an even number of trimmers. If you're going to have 2 on one side, you need 2 on the other.